Good morning and happy Halloween. Today is Wednesday, October 31st, 2018. Welcome back to Thoughts from a Dizzy Dude. I'm your Dizzy Dude, Adam Tilted. And behind me is the haunted house, Das Geisterhaus. I'm assuming that's in Germany. This photo is attributed to, the haunted house, Harold Hoyer. Thank you for your picture, Harold. You can look him up on Wikipedia Commons. Okay, so this is not the show I had planned for this morning. However, I woke up to some not exactly unexpected news, but sad all the same. The Kepler Space Telescope has been operating in deep space for 9 years. Deep space. I mean, it's in a highly elliptical orbit, and it's pretty far away from Earth. And Kepler was the first observatory to be designed for the specific purpose of looking for planets outside of our solar system. Now, planets had been detected through other observations, like radio telescopes. There was evidence that there were planets, but we didn't have any direct observation of them. So, that's where Kepler comes in. Kepler uses the transit method that I talked about with Spitzer. If you missed that one, go back and check that out. But basically what it does is it looks at a star and measures the amount of light coming from the star, and it looks for changes in the amount of light. Because if a planet passes in front of a star, then it will... then it'll go behind my face. If a planet passes in front of a star, then it will dim its light just a tiny bit. Now, obviously not much, because stars are really, really bright and really, really big, and planets are not. So we're talking really, really precise measurements. And scientists compared it to being able to detect a flea crawling across a car headlight from 1,000 feet away. So, that's kind of crazy. But Kepler blew our minds. Seems like that's always the case, huh? When we do these grand missions, our minds are blown. Kepler has confirmed... Let me make sure that I get this right. Kepler has confirmed over 2,400 planets outside of our solar system. Is that right? On tomorrow night's episode of Orbit at a Tilt, I'm going to be doing a special on Kepler. So make sure you tune in for that at 7 p.m. Central Time. Kepler, before I let you go today, though, I just want to tell you a few interesting things about the mission. Not only did it show us that there are thousands of planets outside of our solar system, it also showed that there are thousands of planets that could possibly support life. Most notably, when I was talking about the Spitzer telescope, how they used the Spitzer and Kepler telescopes together to examine the TRAPPIST system, that system alone has at least 3 planets that probably could support life. 35 years ago, we didn't know of any planets outside of our solar system. Now we know of thousands, and there are tens of thousands more candidates that are just waiting for more data to confirm that they are planets. So the Kepler telescope originally, let me switch over to here. This is not the picture I wanted to show you. Originally, in its first mission, it was aimed at one point in the sky for 5 years. And it examined just those stars for that long. And if you think about what it's doing, you can imagine why. Because it's trying to detect planets blocking the light from their sun as they orbit. So if you were trying to see our planet, you'd have to wait a whole year to see it come back again, right? So most of the planets that Kepler has found are close to their sun because they orbit faster, which means that there's more opportunity to see it pass in front of the star. Okay? Does not necessarily mean that that's the most common kind of planet. It's the easiest one for us to detect right now. So this was the mission until 2013. Well, then a couple of the gyroscopes failed. They used gyroscopes to help aim the telescope and keep it pointed in the right direction. So they devised another way of controlling the spacecraft, which is really cool. Let me see if I can zoom in on these parts here. All right, so if you look over here, because the gyroscopes and the reaction wheels are not all functioning properly, they're using the pressure from the sun to help balance that out. So down here, if you look, this is looking down on top of the spacecraft showing the solar pressure. If the solar pressure is unequal, then that causes the spacecraft to turn. And normally those gyroscopes would prevent that from happening, but it can't do that. So now they are putting the spacecraft in a position to take advantage of that solar pressure to help keep it stabilized. Genius! Genius. And you thought that was just light, right? So now it's in its K2 phase. Well, it was until last night. And then finally, the final pieces are broken down. It's out of fuel. And it's done. The good news is that there's a replacement are ready to go. In fact, it's already in orbit. The second mission that NASA has to study extrasolar planets outside of our solar system, is called TESS. And I'll be talking about TESS later, but if you want to check out NASA's website, they have a really good section on TESS. They also do on Kepler, so go check that out. Remember that I'll be doing a deeper dive into Kepler. We'll talk about some of the amazing discoveries that we've learned, and also take a glimpse at TESS and see what's happening there, what we've already learned, and what the future of this kind of observation is, now that Kepler is no longer functioning. Have a safe and happy Halloween. Tune in tomorrow night at 7 p.m. Central Time for Orbit at a Tilt. We'll be finishing our conversation on Kepler, and I'll see you tomorrow morning for another episode of Thoughts from a Dizzy Dude. Until then, be scary.